Are you ready?
Is it like Christmas or what?
Better than Christmas.
We've come a long way to get to this point, from running solid copper bus bars the length of the hull, to mounting not one, but two electric motors in parallel with a Nani N480 diesel engine, from designing a high current backbone instead of relying on traditional battery cable runs, to measuring, crimping, routing, and labeling every single conductor ourselves. It's a lot of planning, engineering, and rethinking how boat electrical systems are normally built. Because when you're integrating hybrid propulsion, distributed charging sources, and serious power loads, the standard approach just doesn't cut it. And none of it works, not reliably, not safely, without putting a lot of thought into how it all ties together. But how? Well, with this custom-built DC distribution system, the nervous center of the boat. It's not just another panel, it's what ties the entire system together. And in today's video, we're going to show you how.
A couple of very cool boxes arrived that I've been waiting for a while. It's from, I'm going to terribly mispronounce this, Ritari per Koya, Finland, from Simply DC. Marcus and I have been working together on this for since the very beginning of the year. It's been a couple of months. This is all the high power DC stuff that I talked about in our electronics diagram.
As I've mentioned, this has been in the works for over a year now, and we've touched on it in a few of the last episodes. The Simply DC boxes are a core part of our electrical schematic. Marcus from Simply DC and myself designed it out carefully, circuit by circuit, thinking about loads, fault protection, serviceability, redundancy, and future expansion. In our interview with Mike from Sea and Land Yacht Works, we dive deeper into the philosophy behind it all. But at a high level, these Simply DC boxes act as a structured distribution hub. They consolidate all of our batteries, the main propulsion and house bank, 12-volt buffer bank, and even their starter batteries, and route them into a common DC bus architecture. Instead of stacking lugs on battery posts or creating a spider web of inline fuses, everything lands cleanly inside the Simply DC boxes, keeping the system organized and electrically sound. From there, the main bus bars distribute power to individual DC loads. Lighting circuits, pumps, navigation gear, communications, refrigeration, each has its own protected branch circuit. It creates a centralized system where every load is traceable. If something trips, you know exactly where to look, and it's very easy to isolate a battery bank or a circuit. It's only a single switch away. It also allows us to integrate charging sources, hydro generation from the hybrid system, solar charge controller, shore chargers, all feeding into the same DC backbone in a controlled manner. With correctly sized bus bars and proper cable gauge selection, voltage drop is minimized and current flow is predictable. The result is a clean, scalable DC system.
For this to arrive is a pretty big deal. There's two huge boxes. Are you ready?
Is it like Christmas or what?
Better than Christmas. Oh, look at this. I know exactly what this is. Look at that. This is all the connections for the motor. So these are the negative connections, 48 volt, positively fused connections, showing all their ratings. And then if we look at this side, big backing plates.
Oh, so they put it all together too.
Mm-hmm.
Nice.
Pretty sweet, huh?
Yeah.
So these two should be a mirror image of each other. So this one's going to be for the starboard engine room. There's the connection to the bus bar right there. Wow, it looks really nice.
The bus bar connects to this, and then that distributes all the power.
All the fusing and all the power distribution stuff internally. Same with this one. See how the bus bar connection is on the opposite side there. So that's good news. Those two are exactly what I was imagining.
How exciting.
Very cool. You know how much work this is going to save me? Seriously, heaps.
Yeah, I'm not kidding. This basically replaces those massive DC panels you normally see on bigger boats. What this does is condense all of that into a compact, purpose-built enclosure. The bus bars are internally mounted, the interconnects are pre-engineered, and the high current paths are short and direct. We've got internal bus structure handling the main positive and negative distribution with a proper spacing, insulation, and mechanical support.
I can definitely tell there's a lot of conductor in there. It's not light. Really well packed. Oh wow. So this is all the DC distribution stuff. This is the technical space forward, where the batteries are. So this is battery 1, 2, 3, 4, 5, 6. So we have 6 banks of batteries, right? Each of those go into here. They're all properly fused. And then here's our shunt. So this box contains the smart shunt that basically is the ammeter that measures how much current we're using, how much power we've used. And then this is the distribution side. So to our bus bar, our grounds for the holes, and then these will go up to another board that then will have individual breakers for like windlass, for the 12-volt system, for all the lighting products, for everything. Windlass, sorry, say windlass?
Yeah.
So this thing kind of ties it all together.
Nice label. So how many months in the making is this?
I think we actually started talking almost a year ago, and then we started working on the specs and requirements in conjunction with Mike at Sea and Land to come up with the drawings, and it kind of evolved over, I think about 6 or 7 months of kind of like meetings and going back and forth to get everything the way we wanted it. Of course, some of our requirements changed during that time because I found out new things that we needed to add. I found out some things that we needed to remove that we didn't need anymore. And I think they just did a fantastic job. I couldn't be happier. This is going to save weeks and weeks of time, seriously, of wiring all this up and just all the fusing and the contactors. And basically, I can just bolt this straight to the wall and then we start running wires to it.
And then you have some other connector thingies. And
Yep, spare parts, spare fuses, spare contactors. There's a bunch of requirements for lithium batteries that you're supposed to do, and involving fusing and mechanical contactors so that if something does go wrong, you can immediately turn them off without having to dig around and unhook cables. So that's what these contactors are for. Each bank of batteries has one of these, and then they're all linked together with a single switch. So if something bad does happen, I can to shut everything down. I have one button we can hit, and it basically turns off the power to everything. So these take one big feed of 12 volts, and it gives me individual fused outputs for the small load, like 12 volt DC stuff.
Morning guys, it's been pretty busy at the Bill lately, and I hope you like all the technical stuff we're getting into in this week's episode. I'm just about to prepare some breakfasts and lunches for the day, and we haven't chatted a lot about our morning routine, but it usually looks something a little bit like this. The alarm goes off at 6:30 and Brian jumps on the computer and I start getting the lunches sorted. And we don't really eat breakfast kind of straight away. We have our first smoko at 10 a.m., which is yogurt and cardboard cereal, like Brian calls it. But before I even start packing lunches, I grab my AG1 and I like to mix it with 8 ounces of cold water, give it a good shake, pour it in a glass, and just sip on it while I'm prepping everything for the day. And I'm genuinely happy to be sponsored by a brand that we've used for so long, as you guys know. So thank you AG1 for being the sponsor of this week's video. It's the perfect time to give it a try, so click the link in the description below or the QR code right here on the screen. And for me, AG1 is just an easy daily health drink that just covers a lot in one scoop. It's clinically shown to support gut health and help to fill common nutrient gaps. It's got 75 plus ingredients, including 5 clinically studied probiotic strains. So it replaces the need to take multivitamins and probiotics and a bunch of other things that I'll probably forget to take anyway. What I've noticed is like a steady energy stream throughout the morning, and especially since I'm not like sitting down for breakfast straight away. They now have some really fun new flavors, but I still feel like the original one is my favorite. So no matter how busy things get, it's kind of my simple daily anchor. So use 1 scoop and I know I've done something solid for my health before the day even properly begins. So give it a try if you haven't already through our link. Get an 81's flavor sampler, a bottle of vitamin D3 plus K2 free in your welcome kit with your first AG1 subscription, a $72 value. Okay, now back to Brian at the shop.
I'm gonna start mounting the Simply DC electrical boxes that arrived. I found this piece of scrap, it's angle, and my plan is to cut this up and put it vertically against the forward bulkhead. I can tack weld it, and it's thick enough so that I can tap that, and then that'll serve as my mounting point for the Simply DC boxes. And I've also gotten out the old bus bar, the infamous bus bar, to see how that's going to connect up into the box. I think it's going to work pretty well. I'm going to have to put 190-degree bend, which I can do now because we have the benda. But anyway, yeah. I'm excited to get this in and get it started. It's been a long time coming. Basically what I'll do is I'll just do a little tack, and that'll hold it in place there, and then I can fine tune it and adjust it a little bit. I think I got it pretty close though. Just needs to come that way a tiny bit. So I'll just adjust that, tack it, and then when I get it all set, then I'll weld it. All right, I've got my basic frame in here, just tacked in 3 places. I put a support on the bottom that's level, tack 3 places over here. Now I'm gonna see how it fits, and then it's time to go home. I don't know what time it is. I think I stayed a little bit late today, but I'm tired and hot and sweaty and hungry, but I gotta see how this thing looks before I go home. All right, I'm gonna grab it. Hang on a second. Okay. There she is. That looks pretty cool, huh? Check it out. That's how it'll sit. Right like that. And then another one will go on top. So then the distribution one, or the one to connect all the batteries together, will go right on top. Yeah, it's coming together. All right. Maybe I'll weld this up tomorrow. All right, good night, see you tomorrow. All right, I'm working on connecting up the cool electronic components from Simply DC today. And so I'm starting out with some of the bus bar, copper tin bus bar. And I've got one section cut to length, and what I'm going to do is I'm going to make some 90-degree ends on the bottom so that I can come down and then make a turn. And for that, the bender seems to work pretty good. The bender. Let me show you.
What's going on in this hole?
Well, I spent the last yesterday building that bracket in the back with the Simply DC parts, and now I'm hooking up the bus bar to it, so the bus bar enters.
So you have pieces of bus bar here.
Mm-hmm.
It all is gonna connect in there, huh?
Yep. Pretty sweet, right?
Cool. Is it hard to connect it? Like, is it tricky, or is it pretty much just like drilling holes and?
I mean, it's just, you can bend it in 90s, and you can, bolt it together in 90s, like horizontally. So, yeah, I'm just cutting, measuring, cutting pieces.
Because it's gonna have to take a turn there, right?
Yeah. This piece goes in the bottom like this. The very bottom. And then I need to put this channel in here.
Okay.
At the right height. And then I'll have another piece that lays on top of it.
And then it comes up in there.
And then these final pieces they'll bolt onto that.
Cool.
Yep.
Pretty exciting.
Yeah. And once this proof of concept works, then I'll be able to do it in either engine room. There's another one of these.
Yeah.
So this is where all the power comes in to the system, and then at the back where it goes out, and it also takes in the power generation from each electric motor, because those can also produce power themselves from hydro or the engine running. And we'll have the solar back there, the solar charge controllers. So this will complete the ends of the bus bar that I started last year.
Wow.
Yeah.
This kind of work gets me in the zone. I've done it before and learned from previous missteps. So I just let the flow decide what's next, and everything is gonna fit just perfectly. Well, today I'm continuing on with a project that I started last week, which is installing the rest of the bus bar. It's the backbone and the bus bar, but I called it the bus bone. That'll work. We'll call it the bus bone. Anyway, I've got the forward part in, so this is the Simply DC components. So if you can imagine, all of the batteries are going to be located up here. All the batteries are going to come together into a junction, and then they connect to these boxes here, right into these terminals. And then we have our DC shunt right here. So the shunt is a 2000 amp shunt, which measures the current going into the batteries and out of the batteries. So it's got to be the first thing in line. But basically what happens, power comes to here, it goes through the shunt that measures the current, and then it starts getting distributed out to different parts of the boat. So what we have to do here is we have to get a whole bunch of power back to the stern of the boat where the motors are. So what we've done is we have all this bus bar in here that organizes it really nice. This is an incredible piece of hardware, because if we were to do this all normally with wiring and fuses and connectors, it would just take up a huge amount of space and be very awkward to deal with. But this is a piece that I can just bolt in there, connect up, and then it's good to go. So we've got power coming in, it goes through the shunt, and then it connects to the bus bar, which runs down, over, and then it goes to the end of the boat. And then we have also fused connections for some of the other high current DC items that are 48 volts. Like an example would be the 48 volt inverters. We're gonna have two 5,000 watt inverters for a total of 10 kilowatts of inverting capacity. We have the windlass that's 48 volts, and a lot of the DC to DC converters that are going to step down from 48 volts to 12 volts for all the navigation and the Selden system and all that stuff. So what we're doing today is we're installing the other end of this. So now that we've got the power into the bus bar and to the back of the boat, we need to get it, we need to do something with it. So the bus bar, if you remember, it kind of travels this way. It goes under the floor. There's a splice in here, and then it goes out to either engine room. And so this is the opposite side. So this is the engine room side. So the bus bar comes in and connects right here. Negative on the bottom, positive on the top. And then we have all of our labeled connections. These are the negative sides for electric motor, electric motor, electric motor, 3 big cables. And then we have our fuse connections on this side, 250, 250, 250 positives. And then we have our other connections and negatives that'll be for things like the solar charge controllers go back here, and anything else that requires a bit of power at 48 volts will connect down here. For example, the flat winder. So this guy, for the main traveler, this is a 48 volt system, 2000 watts power, 60 amps. So when I run the cable down for that, it will connect down here into the engine room. So what I've been doing is I've been prepping all that today. Last week I actually welded up the mounts for this. Let's get down there into the engine room. So last week, this is the bracket that I welded up. It is nice and straight and level. And here's where our bus bar exits. So you can see the gap between them. We've got 6 millimeters of solid glass in the middle and 2 millimeters all the way across with the air gap. So a total of 8 mils between the two. And let me show you how this fits. So this piece fits up here like that. So what I'm going to do is I can drill and tap straight into this aluminum. I can screw that piece up there. I have my bus bar connection that comes down to like that. And then it's pretty cool. This is going to save me a lot of time and a lot of space. I'm really happy with this product from Simply DC. Check them out. Anyway, that's what I'm up to. I'm off. Okay, so we are in the port engine room, and I wanted to show you the progress that I had made on connecting up the rest of the bus bar. So last week, or was it the week before, I can't remember, I did the forward part of the bus bar. That's the part that takes all the power from the batteries and puts it into the bus bar. And now we're in the engine rooms and we need to get the power to the electric motors and all the equipment in the engine rooms. And so here's how it turned out. I think it turned out really nice. So this is the box from Simply DC. It has my contactor in here so that if I'd like, I can shut off power to this engine room for maintenance or for an emergency or something like that. These are for solar charge controllers and DC to DC converters and whatever else I need at 48 volts in the engine room. And then I did make one slight change to the design because it turned out that it was a lot easier to run 95 mil squared Vetus high flex cable rather than route the actual bus bar into this box. And so I was able to make a nice 90-degree turn. You can see the bus bar coming right out of the boat here, so you can see the insulation gap in between 48 volts, and then it comes out and then goes straight into the Simply DC box. The reason I was able to do this is because, remember, the bus bar is just over 500 mils squared of wire, but because we are only dealing with one engine room at a time, we only actually have half the power going to either engine room. And so I was able to use this many cables, whereas if I would have done this up front, it would have been twice this, which quickly gets unmanageable. But here I was able to do, these are 95 mil squared cables, so it's just under 300 mil squared of positive, and the same for negative, so 3 of each, which is enough for one side of the engine room and one electric motor, especially on a short run like this. And I think it was just nice to run. So yeah, so this is what it's looking like. It's looking very cool. Let me actually show you what the other side looks like, because this side is not finished. I still need to insulate and cover up this. Let me show you what it looks like in the starboard engine room, because it is actually finished. So we are now in the starboard side engine room. You can see the same thing with the 95 mil-squared cables, and I've actually extended the bus bar out with the insulation in between them with this channel, so the whole thing is now sealed up, isolated, insulated, and we're getting pretty close to be able to pump in some real power through this thing. I've done a bunch of continuity tests and low voltage tests, but now that I have this hooked up, we can actually put a couple of batteries up front, a couple of 48 volt batteries, and then we're really not that far away from being able to hook up the electric motors or some of the higher power DC items back here. Certainly probably the first thing we'll test will be the flatwinder, so that's 48 volts. And under full load, it's a 2 kilowatt motor, I believe. So still a fraction of what the electric motors will be, but it's at least something. And also that's 2 kilowatts at full load. So without the sail and everything loaded up on it, it'll probably just be a few hundred watts, but at least it'll be a proof of concept. And yep, every day we make a little bit of progress. Yeah, so I got the Simply DC box installed. We're in the starboard engine room right now. So the power is coming down the bus bar, and then it makes a T in the aft cockpit, and then it comes over to the engine room. So I want to show kind of why I think it's cool, because it's an incredible use of space, and these boxes have been very well thought out. So the power comes in, and then it uses these bus bars. On the top is positive, on the back is negative, and then they're separated by a piece of plastic. And then each place where you need a power coming out or a fuse, they're drilled and tapped onto, and then you have these lugs for the cable ends. So if we were to do this kind of like using separate components, I think it would probably take 2, most likely 3 times the same amount of space. Just a very efficient use of space because we're able to stack things in different layers, and all the connections are run internally. So for example, here we have the contactors. So the contactors are embedded in this box, which allow me to shut down power remotely. And then inside this one, these are fused motor connections, 250 amps each at 48 volts. And if you get this guy off, you can see how the fuses are actually embedded in there. So instead of having another wire and a separate fuse holder and then another wire that then connects to the motor controller, it's all right here. So just take this off, undo this nylon bolt, and then you can replace the fuse right there. So,
Wow.
yeah, I think it's pretty cool.
That's awesome.
Hi guys, thank you so much for watching all the way to the end of the video. It was quite a technical one this week, but I love deep diving into some of the technical stuff. And if you have any more questions, you pop them in the comments below. I will try to answer them for you. Next week, we're actually gonna deep dive also into all the batteries and the battery setup we're having, so don't miss that, and we'll see you guys next Friday.
Turn that fan off with all this shit stacked in the way. Sweet.
Oh. Oh no.
Oh gosh,
Oh no.
make a terrible mess.
This is going to be the end of the video. So, if you feel like it, do you mind just saying like,